Good evening, this is Nithya, and my topic for the presentation is Applications of Context-Free Grammar in Speech Recognition. The contents of this presentation are going to be theory of computation, and then we'll move on to what context-free grammar is, then get a brief description about speech recognition, and then how context-free grammar is used in speech recognition, and have a conclusion. Introduction. As Wendell Berry said, we live beyond words, as also we live beyond computation and beyond theory. Words, computation, and theory are being used to make advancements in speech recognition technology and our lives. Through this presentation, I'm going to take you through what is theory of computation, what is context-free grammar, and its applications in speech recognition. Theory of computation. In theoretical computation, computer science and mathematics, the theory of computation is a branch that deals with problems that can be solved on a model of computation using an algorithm, how efficiently they can be solved, or to what degree. It studies the general properties of computation, which in turn helps us increase the efficiency at which computers solve problems. This is done when we estimate the validity of the solutions given by the computer through the theory of computation and then alternate the algorithm so that we can obtain a more reliable solution. This is a fast-growing branch that has helped solving problems in many fields besides computer science such as physics, economy, biology, and many others. Here is a present representation of the relation among complexity classes. The knowledge of theory of computation is critical for its applications, which include the construction of intelligent technology, cognitive physiology and philosophy, as well as diverse models of computing such as algorithm, compiler, and VLSI design, etc. Theory of computation is made up of three branches: automata theory, compatibility theory, and complexity theory. Context-free grammar is a branch of automata theory, which is the study of abstract computational devices. Automata theory. This branch was established in the 20th century by mathematicians. The main aim in this branch is to analyze the behavior of the machines and how they solve a problem. The most powerful model of automata is the Turing machine. Computable theory. It is where we are able to formulate the problem using the Turing machine easily, but we can never solve it. In other words, it is when the computer is able to address the problem but unable to come up with the solution. Computational complexity theory. The complexity theory discusses the efficiency at which a problem could be solved. This is done considering two major aspects: time complexity and space complexity, which are the measures of the number of steps needed to analyze to solve the problem. In order to predetermine the space and time that will be needed, computer scientists link these two factors to the amount of input that was received, as the time and space needed increase linearly as the amount of input increases. Let us talk about context-free grammar. The context-free grammar (CFG) is a way of describing a language drawn from a useful set of languages called the context-free languages (CFLs). All regular languages are CFLs. Not all CFLs are regular. CFLs are useful for describing nested structures, example, expressions with properly balanced parentheses, that occur commonly in programming languages but are known to be not regular. Context-free grammar consists of the following components. Terminals. Terminals are the set of symbols or alphabets, variables. A second type of symbols that can be replaced, usually represented with capital letters, generates a set of strings. Substitution rules or productions or simply rules. Rules that dictate how a variable gets replaced. The left-hand side has the variable that is to be replaced and the right-hand side has the replacement content. Next component is the start variable, a special variable from which the process starts. A context-free grammar provides no mechanism to restrict the usage of a production rule. That is, A produces alpha with some specific context, unlike other types of grammars. This is why it is called as context-free grammar. What is speech recognition? Speech recognition, Or speech to text is the ability of a machine or a program to identify words spoken aloud and convert them into readable text. Speech recognition uses a broad array of research in computer science, linguistics, and computer engineering. Speech recognition is already a part of our everyday lives, but for now it is still limited to relatively simple commands. As the technology advances, researchers will be able to create more intelligent systems that understand conversational speech. Given current trends, speech recognition technology will be a fast growing and world changing subset of signal processing for years to come. In speech recognition, a computer system attempts to identify a sequence of words from a speech signal. One way to improve the accuracy of the recognition is to limit the recognition to a set of selected phrases. This is typically done by limiting valid recognition hypotheses to phrases that are found in a context-free grammar. Speech recognition systems use computer algorithms to process and interpret spoken words and convert them into text. Speech recognition software must adapt to the highly variable and context-specific nature of human speech. The software algorithms that process and organize audio into text are trained on different speech patterns, speaking styles, languages, dialects, accents, and phrasings. The software also separates spoken audio from background noise that often accompanies the signal. Various algorithms and computation techniques are used to recognize speech into text and improve the accuracy of transcription. Below are the most commonly used methods: natural language program processing (NLP), hidden Markov models, engrams, and neural networks. Let us talk about context-free grammar and speech recognition. The present invention includes a context-free grammar (CFG) engine which communicates through an exposed interface with a speech recognition engine. Context-free grammar engine, in one illustrative embodiment, handles loading and unloading of grammars, as well as maintaining a desired activation state for the grammars which are loaded. Further, the CFG engine represents all loaded grammars and their corresponding activation stages as a single grammar to the speech recognition. In yet another embodiment, the CFG engine can be called through an interface by the SR engine to perform parsing services. This relieves the SR engine of substantially all tasks except simply recognizing speech from an input signal. The set of interface methods are also provided, such as speech recognition engine can query the CFG engine about new grammars, words, transitions, and rules. This allows the SR engine to build an internal representation of the active grammars maintained by the CFG engine. In still another embodiment, the CFG engine builds a rich structure from the recognition results provided by the speech recognition engine. This result is in turn provided to the application through exposed interface methods. When we talk about context-free grammar and speech recognition, we can talk about stochastic context-free grammar (SGFG) and probabilistic early parser is used to generate word transition probabilities at each frame of a vertebrate decoder. SCFG as language model improves word error rate from 34.6% bigram to 29.6 SCFG, and the semantic sentence recognition error from 39.0 bigram to 34.6 STFG. In addition, it can further reduce the 28.8% word error by mixing the bigram and SCFG LFs. The context is based on the Berkeley Restaurant Project, with medium vocabulary of 1,300 words, speaker-independent, spontaneous continuous speech understanding system. A vertebrate decoder uses the Viterbi algorithm for decoding bit stream that has been encoded using a convolutional code for Trills code. Here's the representation of the voice recognition, where the voice, where it goes through speech enhancement, then the feature extraction is taken. It is taken to the speaker modeling for the training of the system and the feature matching, which is the test. And then there's the decision, which goes to the speaker's database and then comes back to the feature matching again, goes to the destination and goes to the speaker ID. While the context-free grammar in speech recognition has resulted in many researchers use CFG to generate or filter the word transition list, but not to assign probabilities. Koteu in 1992 extended these results by using a probabilistic LR parser to produce word transition probabilities. The BERP system, a speech understanding system, has been augmented, which answers questions about restaurants in the city of Berkeley, California. Number of researchers have proposed ways to use the natural languaging program backend information in the speech recognition process. BERP consists of the RASTA PLP feature extractor, a multi-layer perceptron MLP phonetic probability estimator, a Viterbi decoder, an HMM lexicon, a natural language interpreter, and which incorporates a stochastic context-free grammar and a database of restaurants. The tight coupling systems were tested on a test set of 364 sentences drawn from the same corpus as 4786 sentence training sentences. SGSG gave a 5% absolute improvement in the word error over the bigram, significant at the 0.005 level. It is to be noted that compiling the SGFT into a bigram preserved the most successful information. Adding the SGFT to the SCFT bigram only produced a non-significant 0.8% absolute reduction in word error. Many advancements in the area are to be made. With the above-mentioned results, the experiment makes it clear that the use of SGFT information can significantly improve recognition performance. It was interesting to note that compiling the SGFT into a bigram preserved the most of the useful information. Adding the SGFT to the SGFT bigram only produced a non-significant 0.8% absolute reduction in the word error. Well, the summary to this presentation would be that many developments have been made on usage of context-free grammar in speech recognition for the past few years, and many experiments are being conducted to make significant improvements in the same. Advancements in this field allow speech recognition to be faster and more accurate. When the flowchart of the speech recognition goes as the acoustic, which is a sound wave, to a frequency spectrum, and then to the features, phonemes or the context, which again goes to the phonemes, then it goes to the phoneme sequences, which are also known as words, and word sequences, which are sentences. Thank you.